Hello viewers, in today's class we are going to discuss another important problem from integral inequalities. So here in this session we are going to prove this important integral inequality in which we have to prove that the integral from 0 to pi by 2 e raised to minus 2 sine x dx is less than pi over 2e times the hyperbolic sine of 1, right? So let us start. So now to prove this integral inequality, we'll start with a function, say f of x is equal to sine x over x, right? So we'll start with this function, and first we'll prove that this function is a decreasing function in the interval x belonging to 0 to pi by 2. So here the limits of integration are from 0 to pi by 2. So we'll consider this interval, right? So we'll prove that this function is a decreasing function in this interval 0 to pi by 2. So now let us first find out the derivative of f of x. So f prime of x is x times the derivative of sine x is cos x, and then we have sine x, and derivative of x is 1, and here we have x square. So we have used the quotient rule for differentiating sine x over x, right? So now we can rewrite this expression by taking cos x as common. So we have cos x, then we have x minus sine x over cos x, right? And here in the denominator we have x square. So now we can write cos x divided by x square, and we have x minus tan x, right? Sin x over cos x is tan x. So now from elementary trigonometry, we know that when x belongs to the interval 0 to pi by 2, then x is always less than tan of x, right? So this is the result which we are going to use, right? So here we are not going to prove this result. So when x lies between 0 and pi by 2, then x is less than tan x, right? So this implies that x minus tan x is less than 0. So this quantity is less than 0, and in the interval 0 to pi by 2, cos x is a positive quantity because we are in the first quadrant, 0 to pi by 2, and in the first quadrant all the trigonometric functions are positive, right? And x square is obviously positive, being a square quantity, right? So now f prime of x is equal to, in terms of only sign, that is cos x is positive, and then x minus tan x is less than 0, so this quantity is negative. So here we have negative quantity, here we have positive, and x square is positive, right? So overall f prime of x has a negative sign when x lies between 0 and pi by 2, right? So when the derivative is negative or less than 0, then we know that the function f of x is a decreasing function in the given interval as 0 to pi by 2. So we have established that f of x, which is given by sine x over x, is a decreasing function in the interval 0 comma pi by 2, right? Now here we'll use another definition of decreasing function. So the definition goes like this: let x1 is less than x2, right? So if we take any 2 points x1 and x2 in this interval, that is 0 to pi by 2, then since this function f of x is a decreasing function, so the value of the function at x1 should be greater than f of x2, right? So this is another definition of decreasing function. If x1 is less than x2, then fx1 is greater than f of x2. So now let us take x1 as x and x2 as pi by 2, right? And here x is less than pi by 2, right? So using this definition, we have f of x is greater than f of pi by 2, right? So what we have done here, we are taking x1 as some point x in this interval and x2 as pi by 2, right? So x is obviously less than pi by 2 as we are given in this interval, that is x belonging to 0 to pi by 2. So f of x, that is f of x1, should be greater than f of pi by 2. Now f of x is our function sine x over x, right? And this is greater than f of pi by 2. So f of pi by 2 can be obtained by taking x is equal to pi by 2 in this expression, right? So we have sine pi by 2 divided by pi by 2, and sine pi by 2 is 1, and here we have pi by 2, so this is 2 over pi, right? So we have established that sine x over x is greater than 2 by pi, right? So we have also proved an important inequality, that is sine x over x is always greater than 2 over pi in the interval 0 to pi by 2, right? So now we'll proceed from this inequality to get this integral inequality. So now let us multiply both sides of this inequality by 2. So we'll get 2 sine x over x greater than 4 over pi, right? Multiplying both sides by 2. So now multiplying both sides by x, we'll get 2 sine x is greater than 4x over pi, right? Now let us multiply both sides by negative 1. So we have minus 2 sine x is less than minus 4x over pi. So multiplying this inequality by negative 1, the direction of the inequality get reversed, right? Now see, here we have e raised to minus 2 sine x. So what we will do now, we'll take the exponential, that is will raise these two quantities to the power of e. So we have e raised to minus 2 sine x is less than e raised to minus 4x over pi, right? And the direction of the inequality remains the same because the function e raised to x is an increasing function, right? So this is the concept here. So the exponential function is an increasing function in this interval that is 0 to pi by 2. So e raised to minus 2 sine x is less than e raised to minus 4x over pi. So now let us integrate both these functions from 0 to pi by 2. So we have 0 to pi by 2 e raised to minus 2 sine x. Here we have dx, and then we have 0 to pi by 2 e raised to minus 4x over pi, and here we have dx, right? So here also we have used an important concept from definite integrals, that is, if we have two functions, say g of x and h of x, and g of x is less than h of x, then the integral of g of x from a to b is less than the integral of h of x from a to b. here a is 0 and b is pi by 2, right? So let us denote this integral by I for simplicity. So we have here I. So I is less than 0 to pi by 2 e raised to minus 4x over pi, and here we have dx. So now let us integrate this function e raised to minus 4x over pi. So we have I less than the integral of e raised to minus 4x over pi is e raised to minus 4x over pi, and we'll divide e raised to minus 4x over pi by minus 4 over pi, right? And the limits of integration are from 0 to pi by 2. So now we have I less than minus pi by 4, and then when we take x is equal to pi by 2 here, then we have e raised to a minus 2, right? So pi and pi get cancelled and 2 2s are 4, so we have e raised to minus 2, and when we take x is equal to 0, then this whole quantity is 0, so we have e raised to 0, and e raised to 0 is 1, so we have I less than minus pi by 4, and we have 1 over e square minus 1, so I can be written as pi by 4, and we have 1 minus 1 over e square, and this is pi over 4e square, and here we have e square minus 1. So we have here derived another important integral inequality, that is I is less than pi over 4e square and e square minus 1, right? So this integral, that is 0 to pi by 2 e raised to minus 2 sine x dx is less than pi over 4e square minus 1. So this is also an important inequality. So now to get this term, here we'll make use of the definition of hyperbolic function. So the hyperbolic function of sine x is defined as e raised to x minus e raised to minus x over 2. Now taking x is equal to 1 here, the hyperbolic sine of 1 is equal to e raised to 1 minus e raised to minus 1 over 2. So this is e minus 1 over e over 2, that is e square minus 1 over 2e, right? So the hyperbolic sine of 1 is e square minus 1 over 2e, right? So now this term can be rewritten as, we can write this integral as I. So we have I less than 4 over that is pi over 4e square, and for e square minus 1 we can write 2e times sine of h1, that is hyperbolic sine of 1. So here we have 2e and hyperbolic sine of 1. So now simplifying this expression, so here we have 2 2s are 4 and e get cancelled. So we have I less than pi over 2e times the hyperbolic sine of 1, right? So this is our required integral inequality, right? So this is how by making use of all these concepts we can prove these kind of integral inequalities.